it almost makes you sort of actually pull for having technical gaffes now, right, doesn't it? So it's sort of that. So algorithms, kind of a big deal these days, it seems like, right? And machine learning, kind of, for better or worse, cooking its way into just about everything that we do as technologists, but also in our regular everyday lives. It feels like it's the oxygen that's powering this next generation of interaction and digital product. And it's certainly changing the way that I interact with my clients. As Colin mentioned, I run a design studio called Big Medium in New York. And our thing is basically designing for what's next. How do we figure out how to take advantage of emerging technologies to create new experiences or to design products in new ways? And for the last decade, a lot of that has been how do we push forward, sort of push the frontiers of what mobile can do. But in the last year or two, I've really sort of felt this shift changing, and more it's been about what can we do with machine learning. A lot of this stuff that actually has been unlocked by mobile or sort of made popular by mobile in terms of this idea of being able to have a camera and image recognition wherever you go, popularizing these ideas of what you might do with machine learning. And it really feels to me that if mobile has driven the last decade of product design in the digital space, that machine learning is set to define the next decade. And so we're here to talk about what is the future of visual communication. What's the cutting edge of this? How do we deal with these assets? What can we do with them? And so what we're here to talk about, what I'm going to talk about, is what are the opportunities now when we have machines that can see images, or can create images, or can make decisions based on those capabilities? And what are the opportunities for us in that, but also what are some of the risks? And by risks, I mean the fact that a lot of times the machines don't quite get things right, So we feel this all the time in our regular everyday lives because the world is complicated, right? I mean, how are the machines possibly going to make sense of this, right? This is a tough one. It's like just point your cameras at that Continental breakfast bar out there, and the machines will be like chihuahuas everywhere. I'm going to give you another really challenging one, friends. Are you ready? It's a little bit early in the morning for this one. But yeah. It's hard work, I know, but these are the kinds of sacrifices that we have to make. Image recognition is hard work. All right. Nobody knows that more than my friend PickDeskBot. PickDeskBot is a Twitter bot that basically just takes random images and fires them off to Microsoft's image recognition service and then just sort of says what it is, right? So it's just caption in a picture several times a day. It does pretty good. It's a pretty complicated image, but the robots figured this one out pretty well. It's kind of charming when it gets confused sometimes, It's sort of, it's like, it was pretty close, One of those new Samsung deals. And again, sort of naive when it can't quite understand what's happening, right? So charmingly naive about what's going on, but it's making a pretty good guess. My point is that as we start to work with this, as we start to work with machines that purport to understand images, we have to anticipate some weirdness. So as designers and developers, product managers working with this stuff, I think what we'll find, what I've certainly found as I work more with machine-generated content and images, machine-generated interpretations of content and images, and even machine-generated interaction, my job is less about defining fixed paths through content and experiences, but more about how do I just anticipate all the weird stuff that the machines come with us. So if sort of product design so far has been about designing the happy path to success and really been focused on success, what this era means is that we actually are doing more to design for failure and uncertainty. This is the real challenge, to design to anticipate this fuzzy range of results and confidence. So just over the next 30 minutes or so, what we're going to talk about is how do we use machine learning and machine intelligence as design material as we consider working with images. It is a new kind of design material for us in the digital context. And I want to encourage all of you to get out there and actually start experimenting with this. And we'll talk a little bit about how to do that. I'm going to do this in sort of 3 chapters. One talking about machines that can see, what are the opportunities there. Machines that can create, that can actually make images, impose images on our own reality. And then machines that decide on all that stuff. That sound okay? You guys doing all right? you look great. All right, okay. So let's start with machines that can see. And really what we're talking about is the idea that the camera is the interface. And this isn't entirely new. This has been with us for the last several years of mobile. But it's incredibly mainstream now. And again, I would say ushered in by mobile, the fact that these supercomputers that we have in our pockets and handbags all have cameras attached to them. Really, if you think about it, photos really are the creative unit of mobile. It is the way that we make the most content. We send a lot of text for sure, but man, we take a lot of photos. My daughter, who is 18, must take thousands of photos a day. She's on Snapchat all the time, but she's not taking pictures. She's having conversations. Right? This is the context of what she's doing, where the video camera is the interface and the video is the message itself. So, Snapchat, tilting a little bit as a business. Didn't see a lot of Snapchat hands go up this morning. But they did identify something really important in the phone, that the camera is to the phone as the cursor is to the desktop computer. So Snapchat, a social network for crying out loud, calls itself a camera company. As I said, it's the image as creative unit, as conversation, in the case of my daughter. But as we think about these other opportunities of sort of what happens for people like us when our work often is, I just need some audio here, well, whatever, we'll see what happens. Our work, right, often putting up Post-it notes or whatever, how can we sort of bring that stuff into a digital context? So it's just some simple notions of the camera as interface to bridge the physical and digital worlds, even with sort of something as simple as this. We're going to be hearing a little bit from Ryan from Pinterest later in sort of other contexts, but I wanted to give a shout out to Pinterest with their lens feature. This is a deal where you can just basically take a picture of anything inside Pinterest, and it will find like images, and then you can actually explore those images, things within them, to find sort of matching context and pins. I'm actually going to show this feature using a current pin that's on there already, but it works the same way if you just point your camera at something and start exploring. But the idea is that you just have your picture and you tap the icon, and then you can actually pinch to zoom in on an aspect of it, and you see it'll find some matching photos and images, as well as the metadata that's associated with that user-associated metadata. So you can explore a whole image and then sort of bounce around, see what I did there, to different images and explore those as well with this combination of image recognition, but also user provided data. So you've got this sort of rich kind of thing of where your users are training the algorithm about what the images are and being able to explore the world in these ways. So the point of these examples, this idea of camera as interface, is that what it really lets us do is minimize input to maximize output. It takes very little effort. How can I just sort of point the camera at something? That's the value of image recognition or of machine learning generally, to recognize patterns in the world and make connections among data, that you give the machine the easiest, smallest possible input, and it sorts it out and delivers the value. That's the promise, certainly of image recognition, but also of machine learning generally. So if we're starting to talk about here about what can we infer from an image, just what do I want from an image? What are the associations that are built into that? I think there's also an interesting question here, sort of what can we impose upon the image? And that's really what we're getting at with augmented reality, which has been simmering for a lot of years, but it's starting to get some more traction. Entertainment and games, by far, sort of the biggest use of this. And it really gets at this idea that with augmented reality, you're sort of putting this layer of fantasy in there, this layer of whimsy. So it's really well suited to entertainment and games. But there are more practical applications, too, for exploring the world. Housecraft is an augmented reality app that's built with iOS's AR kit. So augmented reality built right into the platform that lets you use the camera as the interface to place furniture around your house, sort of an instant interior decorator. There's also, by the way, you've got plant mode too, so you can have your plants. That couch, by the way, is brown. I don't know if you guys noticed that. Definitely a brown couch. I thought so too. You can drop your fireplace in there. Don't try that at home. But there's also that destroy mode. And incidentally, you can also just dump 500 chairs into a room because, why not? All right. So there's interior decorating, this idea of that the machine understands the space and the surfaces in your room, and you can actually impose new kinds of things into it, putting images into the real, the image space of reality. So in this case, you can be an interior decorator. But say, instead of decorating your home, you want to decorate your body. Ink Hunter lets you preview a tattoo before you decide to make things permanent.
Taisha is wondering where to place her new tattoo. With Ink Hunter's tattoo app, augmented reality will help her decide. She draws the square smile where she wants to be inked. And, like magic, the square smile disappears and the tattoo appears. All in real time. That's it. Take it from Taisha. Think before you ink.
I mentioned I've got an 18-year-old daughter, and I really endorse this think before you ink kind of process here, by the way. Make good choices, honey. Make good choices. All right. So you might be wondering, hey, this all seems great, but wait a second. I'm not a data scientist. Maybe my company doesn't know anything about this. This is for all the other fancy companies here in San Francisco, right, who are all highfalutin with their fancy algorithms. How do I get in on this? Well, friends, here's the good news, is that this is not just the domain of algorithm engineers and data scientists. Sort of folks who are interested in product design and visual design, UI design, developers, we can all get in there and start playing with image recognition too. So I want to talk a little bit about some of the tools that are available here. Intelligence as a service. I already mentioned that augmented reality is getting cooked into some of the platforms already. In iOS, we were looking at an example of that. But also sort of stepping back a little bit more as you look at Google and Microsoft and Amazon and IBM, all of these companies, as they're competing to sort of hustle for new breakthroughs in machine learning and artificial intelligence, they're also giving it away. Intelligence as a service, intelligence as a utility, where you can essentially subscribe to their algorithms and data models. In fact, machine learning services are becoming a commodity in much the same way as server hosting is. And in fact, these services often are associated with these companies' hosting packages. So here's just one example from Microsoft's cognitive services. You can use, if you use Microsoft's Azure web hosting service, you can get access to all these APIs of vision and speech, language, knowledge, all this sort of search stuff. Amazon, Google, IBM, they all have a similar set of offerings. Microsoft's a great place to play, though, because they have a lot of these services, really fairly easy to use. Just to zoom in on one of them, just for example, we've got Emotion, you guys. The new Emotion API, you can outsource all of your emotional needs to Microsoft. Totally on brand for Microsoft. They've understood emotion since way back. OG emotion with Microsoft, as you know. All right. Let's sort of take a look, actually, at what this thing really does. Emotion API identifies faces and reads their emotion. So at the very surface level, it is facial recognition. It does a little bit more, though, is that for each of the faces that show up in a picture, you get back this information about their emotions categorized around the 8 stages of emotion that we've all felt about Microsoft at one point or another. So this is for the guy here on the left. You can see that he's generally happy with a little bit of neutral. He's got some subtle notes of disgust, sadness, and fear, basically stock photography in a nutshell. It's all right there. But so this is sort of interesting, you know, it's like basically you just upload a photo and you kind of get back this idea of what's happening in this picture. And again, essentially for free to sort of try all these different services. So I encourage you to splash in puddles a little bit with those. I think one of the interesting opportunities, too, is what happens when you start to think about chaining these things to other services. And again, this can be even just sort of simple web-based applications. GeorgioCam is a web-based project from a pair of Google developers developed, I believe, last year. So this is all JavaScript doing the work with these free back-end services that we're about to see to combine camera vision and speech synthesis and web audio to make, you guys, a sentient rapping robot. Okay.
What if the computer turned the things that it saw into lyrics of a song? It could even rhyme about them.
We've got glasses in this spot. Could be eyewear, but maybe not. We've got glasses in this spot.
We had our friends try it out, and had a lot of fun pointing it at all kinds of things.
Is that food I see?
That's pretty close.
That's plucked string instruments on my screen. Could be profession, but maybe not. Nah. Looks like world to me. Digging that camera operator you've got.
Digging that camera operator you've got. Best rap verse ever. So this is just in Chrome and Android, just a web-based thing, smushing together all these APIs and using this sort of fun, interesting way to explore video. So my point here is just with all this is that with sort of, kind of the typical skills of a web designer and web developer, you can start to make these things. So my point just, you don't have to be a scientist. Tons of machine learning services out there waiting for you to use them at low cost and fairly low technical knowledge. What you do have to bring to this, and I mentioned this earlier, is a bit of a tolerance for failure and uncertainty. I mean, as we saw even with that example, it's like the globe is a world, a person working at their desk is a profession. Like some of these things, right? It's sort of how do you cope with and give sort of a soft landing to these weird responses that come back? Because here's the thing, it's like no big surprise, you guys, the machines make mistakes, we feel it all the time. The world is a complicated place, and it's full of subtlety, and the machines aren't so great at subtlety, right? So if we step away from images for a moment, just going to give you a little bit of an example from the world of speech. When speech recognition is accurate, and it isn't always, but even when it is accurate, and we've had this experience, what do those words mean? What's the intent behind the thing that we've asked Siri to do, and why is it so hard for Siri to freaking figure it out, right? There's context, too. Does Alexa understand who's speaking and whether that matters?
The device isn't aware that it's a child versus a parent.
Which is exactly what happened today during our morning show when Jim and Linda were talking about a child who accidentally bought a dollhouse and 4 pounds of cookies.
I love the little girls take on it. Alexa ordered me a dollhouse.
As soon as Jim said that, viewers all over San Diego started complaining their Echo devices had tried to order dollhouses.
I feel like that's pretty good. Kudos to the kids for figuring out how to get 4 pounds of cookies on demand, too, I think, right? So it does, in this case, and all of these services are trying to figure this out, how to disambiguate who's talking and what that means, who has permission to do what. But the point here is that, it doesn't really matter who's talking out loud, even the TV. How do we start to get some of that nuance in there? Devices talking to each other and not knowing the difference. This past season, the season premiere in September of South Park was full of characters talking to Alexa and Siri and Google Home in typically off-color ways.
Alexa, Simon says, I gotta take a stinky poop.
I gotta take a stinky poop.
So the real joke, of course, was on the audience, because if you had an Echo or you had Siri or Google Home in your house, it also followed the commands, right? So your Alexa suddenly had a potty mouth and your shopping list turned a bit perverse. So the machines couldn't tell the difference that it was the TV talking. So who speaks and what's the intention? That's a data science challenge. But I would say that for those of us who are designing products, for designers and developers and product folks, that we have a role here too, because it's a little bit of sort of saying, all right, if it's a given that the results, that the machines may not understand things well, how do we sort of put a rope around there? How do we introduce a little bit of humility instead of just sort of bold confidence into what we're doing? Let's go back to our dinosaur and I'll show you what I mean by this. So here we've got this sort of ridiculous confidence of what this is, right? This is clearly a dinosaur on top of a surfboard. And that's part of its charm, right? Is almost the naive confidence that it has here. But it's expressing a confidence that is unwarranted. And sure, that's a little bit of a data science problem, but I would say that it's really part of the presentation of this very simple thing, that it's suggesting that the algorithm is probably more sure than it actually is. So what if we wanted to try to make this a little bit more accurate, say for people with a visual disability who couldn't see and sort of understand the error that's being made here? When you submit the image to the computer vision API, you actually get back a good bit of information, and we start to see that its view of the image is more nuanced. So if we take a look at this, we see that confidence thing, 0.257? That's saying that it's 26% sure. that it's a dinosaur on top of a surfboard. Not at all confident, even though the presentation and the interface said, yes, very confident that this is true. And yet when you go down here, you see 97% confident that it's a dinosaur. So it's figured out the dinosaur, but it doesn't know what the heck it's standing on. It can't figure it out, right? So as we start to think about what the presentation is, certainly language can help. Dinosaur, maybe on a surfboard, and we can actually start to show what some of the confidence is too. So we're getting there. But the point here is there sort of a body language that we can start to introduce into our interfaces in the same way that we have our own body language to express confidence? And what are some of the things that we can do there to let people know how the machines are sort of self-regulating, how they recognize that they're doing? We can sort of fix it a little bit more and kind of say, you know what, really sure it's a dinosaur? Not at all sure it's a surfboard. You get the idea. These are sort of rough takes at this. But how do we start to surface the actual confidence of this? How do we make our interfaces and our products more honest by introducing a kind of productive humility that kind of says not just, I don't know or I know, this binary idea, but I think I know, which itself is actually a pretty useful notion. All right. So just to sort of round out this first chapter of machines that can see, I just, first of all, think about this. How can we use the camera as a UI? This is something that we've been thinking about as an industry for a couple of years. But again, this notion that it unlocks a lot when you start to realize that the camera is the creative unit of mobile. Photos are the creative unit of mobile. Start getting out there and start playing with these APIs. They are easy to use. They are free to use. And start to see what happens when you start to play with this, particularly around in the context of what we're talking today, the different image recognition APIs. And finally, just know that these things are going to be wrong all the time. Come up with weird responses, and we'll talk a little bit about the implications of that in a bit. But what that means is that we have to design much more defensively as product creators than we used to. Where it used to be much more about designing for success, as I said earlier, it's designing for failure and uncertainty. All right. Failure and uncertainty. Woohoo, good morning. Okay. So what about if we see machines that can create, we're also starting to see machines that, or if machines not just being able to see, but as they begin to understand images, we're starting to see a lot of systems starting to take baby steps into being like, if I can see images, I can also be an artist, right? I'm ready to direct. So there was a machine learning artist in residence at Google who was curious to see about how he might do this and sort of get the machines to start painting. So he used the same algorithm that Google uses to detect faces. I am way oversimplifying this, but basically ran it backwards, right? Sort of using some of that same recognition stuff to sort of say, well, let's see if we run it backwards and start generating images, letting it paint faces based on this same pattern-based model. And friends, it was horrifying, right? All right, it's just like, this is how computers understand the human face, all eyeballs and a slash of the mouth. That's a little disturbing, so let's go to these pictures that were painted by George W. Bush instead, all right. Not a lot better, but there you go. So those other horribly disfigured faces on the previous screen from the last slide actually hint at how the machine considers faces, right? It sort of shows us this is their view of the world as we start to try to understand how the machines see us. Letting them create is an interesting way to do that. And also, by the way, start to improve and understand our image recognition models. If we can kind of see this is what it thinks a face is, we can sort of understand how to optimize for other things. But the stuff they make tends to be kind of creepy. Sort of is a flamenco dancer also sort of created, drawing these strings that one other system did. They're sort of surreal and unworldly. They aren't necessarily not art, but I would say that probably they aren't necessarily the way that we often think of it. Often the machines, at least at this point, they're better assistants than artists. And this makes sense because really they're understanding patterns and copying them, right? They're sort of trying to make sense of what it is that makes a picture and duplicating it. So that means that they're not always great, particularly at original artwork. They're not bad sometimes at cloning existing artwork. But what they can do by sort of using that pattern stuff is enhance experience, sort of alter our perception of the world. And this is related to the augmented reality stuff that we were talking about before, the new experiences that machines can create for us. So by generating new sensory experiences, they become a kind of reality editor. We saw this a little bit sort of step out of images and talk about audio a little bit when Google introduced its Pixel Buds. And so, for example, when you're talking with someone, he's speaking in English, she hears in Swedish.
Hey Isabel, how's it going?
Hej Isabel, hur är läget?
Helt okej, tack.
Absolutely okay, thank you.
What do you think of these cool new headphones?
Vad tycker du om de här coola nya hörlurarna?
Mitt team designade dem, så jag tycker de är ganska coola.
My team designed them, so I think they're pretty cool.
Good for her. Good for her. There's sort of a precursor to this product is something called Hear One that's now defunct. But like the Pixel Buds, they process the sound around you so that you could adjust them to adjust the volume of the world around you, or to tune a concert, to raise the bass or lower it. So you could focus the sound of the person right in front of you or the person behind you. You could, lift the volume of the person you're talking to or mute them. It's like, it depends on how things are going. But the interesting thing that sort of caught my eyes with the CEO of that company suggests that everyone is going to have their own subjective reality for what the world sounds like. That as the machines are starting to intervene on a personal level for what we hear or maybe what we see, how does that change the shared conversation that we have about things? So what happens is we begin to explore new and more immersive augmented reality experiences, like Microsoft's HoloLens or the forthcoming Magic Leap that we see here. The Magic Leap is still not sort of released to the public, but sort of what we're promised is experiences like this, like the videos that they've leaked out, where you can walk around your conference room and find a little robot under there. Or maybe more famous robots, right?
That due to unforeseen circumstances, we have not yet reached the desired arrangement with Jabba the Hutt regarding Captain Solo's death.
Just walking around your conference room. So the interesting thing is when we go from altering perception to sort of outright illusion, and this, of course, has long been the business of Hollywood. More recently, even that entertainment sector has grown a bit complicated, though.
We've heard word of rumors circulating through the city. Apparently, you've lost a rather talkative cargo pilot.
So this man died 25 years ago, Peter Cushing, who played Grand Moff Tarkin in Star Wars, and yet here he is starring in Rogue One, alongside a very young Carrie Fisher, who also conjured into existence for the movie. This is all CGI, of course, kind of grafted onto the actor Guy Henry here. Harmless enough entertainment, but it sparked quite a debate. The Hollywood trade press was full of questions like this. Is it okay, effectively, to bring back a dead actor and repurpose him for a film? Is it ethical? Is it moral? This was the first time that these questions were getting asked about movie CGI effects. And I think, what was it about this case? I think that it had something to do with the fact that this was the first time that Hollywood-style special effects were starting to reach out into the real world, to touch the legacy of a real human being, right? Again, it was illusion, but sort of starting to edit reality in some sense. But it's like, I thought that guy died 25 years ago. It's like, what's his family and estate think of this? I'm sure they got something out of it. But what are the implications of editing reality or history or human legacy, which the machines are increasingly able to do on the fly? So you might be familiar with Face App, which is a smartphone app that lets you edit expressions in photos so you can do this, which doesn't feel quite right, does it? Right? And there's lots of systems like this, toolkits like CycleGAN, which we'll look at here, which use machine learning to make similar transformations on the fly. So CycleGAN is a machine learning network trained on horses or fruit or other sort of familiar objects, and then taught to transform them. So boom, your horse is a zebra, right? So it basically can recognize that and apply that pattern. It's, as with all these things, if things don't quite fit your pattern, you can kind of get some funny results. Vladimir Putin as a zebra. Yeah, watch that guy change his stripes. This is all, I don't know. I don't know. Just dad jokes. Yeah, I got a laugh up here from Colin. Thank you, yeah. So, this is all good fun, but what happens when we start using these tools to manipulate more important imagery? So Face-to-Face is a project out of Stanford that uses a standard webcam. You sit in front of a webcam, and it lets you manipulate the expressions and mouth words that appear in a separate pre-existing video. So this guy is using his face to drive George W. Bush like a puppet, right? Yeah, I'm not even going to touch that one. But what could possibly go wrong, right? What could possibly go wrong with this super easy editing of what world leaders are saying, right? You know, in a darker turn, too, a system called deepfake was open sourced in the last few months to put the faces of celebrities on the bodies of other women, notably in X-rated scenes. And I want to be clear, this is an assault on these women. And the technology makes it effortless. And it's an unsettling thing because it makes it harder to tell what's real when we can't sort of trust our own senses, where sort of imagery has long been this kind of proof. What does this do to reputation and to our perception of truth? And so to come back to this observation that we were thinking about with audio, where everyone is going to have their own subjective reality for what the world sounds like, how are the machines going to change this sort of core skepticism for what we see as well, or all the things that we perceive? And what happens, when we've already sort of gone through this to some level with the age of sort of photoshopping things, but as it starts to get to video and to even to sort of an augmented reality experience, what happens when our senses become unreliable? And is the risk that we're just going to become an ever more skeptical or even cynical community? And I would say that the last thing we need right now is more cynicism. What I will say is that I remain optimistic about the power of these things. There's some real possible downsides, as we've seen, to this, but I'm optimistic. And I believe that people in this room are interested in creating more positive uses, these magical moments. But I think there's probably some opportunity, too, at the same time to help to draw the line between reality and fantasy. And maybe the machines can help there. Maybe we'll all have a browser extension to show us how images and video have been doctored. But it seems like this is going to be an important area for us to explore. So again, as we think about what we can do in this area of machines that can generate images and not just see them, is again, go back and splash in puddles, play with these existing systems. We looked at CycleGAN, other models that are there where you can just sort of run images through and transform them in interesting ways, or create entirely new images like Google Doodles was doing by sort of running it backwards and creating sketches and doodles based on keyword phrases. But also, I think it's our responsibility to be transparent about how and when and why we are particularly changing images and sort of creating some literacy about how do we take advantage of those changes. And for all of us on both sides of both the makers and the audiences, is that we need to sort of engage our critical senses a little bit to understand what's entertainment, what is sort of more being put to darker use. But I think there's sort of some crazy stuff ahead, which is important because these are sometimes machines that are just making decisions for us. What do they perceive? And how do they make changes based on that? Seeing, in a relatively harmless way right now, Amazon Echo's Look, which is the video-based version of Alexa, right? It goes into your bedroom. It promises to help you choose the best outfit based on color and fit and trends and style. But whose style? I mean, is this some normcore normalization of what looks good? Are big corporations now judging our bodies and our personalities? Well, yeah, but of course, everything depends on the variety of data that we feed these systems. Just a reminder, of course, that the machines know only what we feed them. They extract patterns based on the data that we give them. And sometimes they don't always draw the conclusions that we expect. So at best, these moments are charmingly naive, as we've seen. But here's how robots understand human romance. This is a set of machine-generated pickup lines built by a neural network trained with a few thousand pickup lines, right? And some of them are kind of charming. You must be a Tringle because you're the only thing here. That's a little bit confusing, but you look like a thing, and I love you. I mean, come on. Robot love. But the point here, right, the old sort of saw of engineering is garbage in, garbage out. There's no such thing as a good pickup line. They're all awful. And so if you give the machines awful data, it gives awful results. They mirror the system that they're given. And I think it's important to remember that machine learning is all about figuring out what's normal and predicting the next normal thing, or finding outliers, aberrations. You're going to be sick. This is not right. Throw this out. The thing is, though, that the data has to come from this flawed world that we live in. And so there's this question then of what if normal is garbage? What if our machines learn from us our own bad or dubious choices? What if they absorb and reinforce existing inequalities or leave out entire categories of people? And sometimes, you see this stuff in ways that aren't just, oh, that's bad, but are actually outright hurtful. Let's take a look at one example.
All right, so watch this. Black hand, nothing. Larry, go.
Oh.
Black hand, nothing. Larry, go. Racist mother sinks.
How did this happen? I mean, anybody want to bet all white-skinned people on that team, right? I mean, how does this stuff happen? How does this get through? How is this okay? Plenty of examples of this stuff. This is Richard Lee, a New Zealand citizen, and this is the message he saw when he tried to renew his New Zealand passport. Subject's eyes are closed. Making decisions. Nope, you can't have a passport because your face is not normal according to the systems. Bad or incomplete training data. And so with all this, it's like the danger is that we sort of codify all of the sort of past inequalities from our own sordid history. And by codifying the past, this is a phrase that I'm borrowing from the data scientist Cathy O'Neill in her excellent book, Weapons of Math Destruction. On the surface, you'd think that bringing the machines in would help to eliminate bias, right? It's like, it's data, it's objective. But of course, the data is only as good as what we give it. And so in the cases of predictive policing or sentencing algorithm where the data is so completely biased against black men, or hiring and promotion algorithms where you might sort of say, who's going to be most likely to be the next executive, that historical data is biased against women or people of color. So there's a sort of a tricky thing of, as we start to think about how do we interpret images, how do we use this stuff, facial recognition especially a big one, is where should we put our thumb on the scale to sort of say, this is the past and this is the future that we want to have, and this is fraught. Because as we know in our own sort of society, reasonable people can have completely opposite notions of what fairness and justice are. And so how do we who decides? And is that giant corporations? You might remember this one from a few years ago. Google apologized for this instantly. Product lead, clearly mortified, took the necessary actions to get it fixed. In fact, the necessary action was we will no longer recognize what gorillas are, right? So it's putting this value-based thing of we are going to take out the knowledge of gorillas out of this to avoid this larger problem. But the point is that they're putting their thumb on the scale of trying to make an adjustment, and that is a complicated issue. But for us, as we start to work with this stuff, it really underscores the important thing is to find the right data set that matches the people and objects that you're trying to serve or represent. My friends at TopBots did a little bit of a study looking for the best computer vision API to solve this complicated question that we started out with. And it found out that most of the image recognition stuff did a pretty good job of figuring out what was a muffin and what was a dog. Microsoft, oddly, often recognized everything as a stuffed animal. So, which sort of tells you that it's been trained on household objects, sort of a family environment stuff, right? So all these things, it's important to know, as we saw with the horses versus zebras versus Putin, it only knows what you've trained it on. And so finding the right training data and comparing them, testing them is important. But also I would say that it's important to work with people who aren't you. And I don't mean just people of different race, ethnicity, religions, age, geography, but also just different worldviews in general. I love this line from Genevieve Bell, the anthropologist from Intel, about, as this stuff touches everything we do, how do we get philosophers and psychologists and poets? How do we get outside of our tech bubble? So as we think about this, as we think to start to work with images and algorithms to make decisions, one of the big challenges for all of us is to figure out how do we go about rooting out bias? How do we broaden our data? How do we work with and expose our systems to more people? And ultimately, how can we do more to take responsibility for these systems that we're creating as they have more and more scope? You guys, this is an exciting time. And I am optimistic about this, even though I'm showing some of this potential downside. I think there are huge opportunities. And it's a time for all of us, designers, developers, product people, to get in there and to try things, to see what can happen here, but also to realize that this is really powerful stuff. It's working at a scale and a speed that we haven't seen before. And so there are these opportunities, but also responsibilities. We need to take stock of the world that we want to live in and actively apply some of those values to that. Because if we don't decide for ourselves, the technology is going to decide for us. And the last thing that I think we want is the future itself to be self-driving. So the last thing that I'll say to you is, again, this is an amazing time. We're going to hear from a bunch of amazing speakers today about how to use all the tools available to us. So go out there and do that amazing thing. And finally, you are a thing, and I love you. Thank you.